Okay, so now I give you the clicker, and so we'll have they've prepared about 8 to 10 minutes of thoughts, and then we'll open it for a general discussion.
Awesome. Thank you very, very much to the organizers for the opportunity to give this. It's been super fun to be here today, and I think a special treat coming as someone who I do think is reasonably treated as an IO outsider is just getting to sort of learn so much of the intellectual history of the field in a condensed form has been just an incredible treat. So thank you very, very much for the opportunity to be here and for all the great talks. So given the opportunity to be on this panel, I wanted to use my time to talk about empirical I/O, causal inference, and retrospective analysis. So in particular, the comparison here, I think what the organizers have in mind, thinking about causal inference, maybe what I would sort of very loosely term reduced form estimation. So I'm thinking of late potential outcomes model and their various intellectual descendants. And one thing that the structural I/O and reduced form literature share in common is exactly an interest in causal inference, right? So an intense interest in comparing counterfactual outcomes. In particular, both of these literatures are interested in what happens to various objects of interest. Think of observable variables like prices, maybe unobservable variables like consumer surplus in different states of the world. Where a key distinction between these two literatures is that in many cases, at least, the structural literature is far more ambitious, aiming at point identification of causal effects for a given instance, whereas the reduced form literature often focuses on identification of average effects across instances. Now, as already came up in Steve's talk, if I have to make a decision in a given context, the thing that's of course decision relevant is what is the causal effect for the context in which I'm making the decision. I don't care if a given decision would be good on average across other instances I'm not facing. The challenge is that to make point identification of counterfactual outcomes possible, structural models, of course, need additional assumptions, and in particular, assumptions on the outcome model. Now, as we know from Steve and Phil's work, for instance, these can sometimes be non-parametric, at least in many dimensions, but in applications, as we've already talked about today, they're very frequently parametric. Now, those sorts of parametric modeling choices means that estimation of structural models very frequently require the researcher to make a wide variety of choices. These could be things like choices of instruments, choices of functional form, or choice of equilibrium contexts, where in some contexts these choices won't matter, but in many other contexts they will impact the counterfactual prediction that I get. And so the main point I sort of wanted to focus on in this discussion is the value in measuring how well we're doing in making these various choices. In particular, getting better measurements of how large the errors made by structural models are, both in absolute terms and relative to whatever other models or approaches we might want to consider. This is, of course, not at all an original thought. Right? This has already come up multiple times today, thinking about the value of experimentation, thinking about various sorts of, fit a model, roll it out, see how it does, for example, as came up in John's talk a bunch of places. So one instance of this, Naveau and Winston, in a discussion in response to the Anguish and Pischke article, which already came up, is to say that whatever methods are used for predicting the effects of mergers before they occur, retrospective analyses of merger effects can be useful for judging the accuracy of those methods. Now, there's a growing literature that follows exactly this call, right? We've already heard about a bunch of examples today, but couple examples are Peters 2006 on 1980s airline mergers, Bjornerstad and Verboven on a pharma merger. Some of these retrospective analyses consider a group of cases, for example, Peters, while others focus on a single case. And something I do want to emphasize in my comments now is that I think that to the extent it's possible, right, and I recognize this is a huge lift and a huge amount of work, doing systematic retrospective analyses seems especially useful. Right? In particular, it would be especially useful if it were possible to do retrospective analyses across a variety of cases, ideally forming a representative set of applications in some area. Right, now, why am I sort of putting an emphasis on the value in systematic retrospective analyses? Well, to me, right, at least, the question of How well did we do in a given case is, of course, interesting. Right? It's good to know if I did a counterfactual prediction, did I get it right? But on an ongoing basis, the more decision relevant question seems to be, how well does this method do as generally applied? Right? We're having to make a bunch of choices. Those choices matter. It's really good to know sort of when we're having to make those choices before seeing the result, how well are we doing on average ex post? Now, of course, doing retrospective analysis right, even with a systematic data set, faces certain challenges, which are in fact many of the same challenges faced in standard reduced form retrospective analysis of causal effects. Right? In particular, we only observe an outcome for one state. Right? The merger either happened or it didn't. And whichever outcome we get to observe is presumably not random. Right? Merger approval is, in general, not going to be as good as random. Right? So we need to worry about the selection that induces. Right? And for those problems, we can address them, at least potentially, with some of the same tools that come up in other applications of retrospective analyses. Right? For instance, Peters argues that mergers in the 1980s were super loose, so he sort of wants to make the argument that selection's not a big deal. Raval et al. Focus on disaster-induced hospital closures to look at diversion ratios. And we've already heard about experiments. Another example of experiments is Ostrovsky and Schwartz studying a large-scale auction experiment with reserve prices. Now, I do want to note, I think there are other challenges for retrospective analysis of structural models that are a bit more specific and a bit different from what a lot of the more reduced form literature aims at. In particular, as we've already talked about, counterfactual predictions are very often ceteris paribus, but we only actually observe outcomes after a lag. So presumably in the intervening time, other things change too. Right? So basically, if we miss the counterfactual prediction, it could be that my model was wrong. It could also be that other things changed in the interim. In addition, we often care about a model's ability to recover causal effects, right, rather than predicting counterfactuals per se. Right? If I got the causal effect on consumer surplus right, maybe the fact that I sort of predicted the outcome wrong is sort of irrelevant. That said, I don't think either of these is insurmountable in general. For instance, outcomes after a merger actually takes place seem to me like potentially the more welfare relevant target. Right? If doing the ceteris paribus analysis actually does poorly for what's going to happen a year down the road after the merger is actually approved and takes place, that would seem like a problem too and valuable to know. Similarly, the bias and variance of errors for the counterfactual outcome can be used to bound the bias and variance for causal effects, although there is some loss in that bound. So if, again, doing this would be a huge lift, but if we could get more of these systematic retrospective analyses, I think they'd be useful for a variety of purposes, including guiding the choice between different methods of counterfactual prediction, right, which is very often what retrospective analyses are currently used for when they're done, right, sort of is model A or model B better. But I also do want to emphasize, I think it's helpful to quantify the residual uncertainty, even if it's irresolvable, around our counterfactual predictions. Right? It may be that the goal of exactly what's going to predict what's going to happen after a merger is fundamentally hard because the world is fundamentally heterogeneous in ways that our model can't capture. But knowing how big that residual heterogeneity is seems very useful for gauging how much confidence we should have in these counterfactual predictions relative to other sources of information and other policy relevant factors. Thanks very much.
Do I go now? Günter? Okay. All right. Thank you all so much. Thanks to the organizers. Today was amazing. I'm very sorry that I need to fly home right after this and I won't be here tomorrow. I'm sure that's going to be incredible too, looking at the program. I want to start by saying that I think modern empirical I/O is an enormously successful enterprise. We've heard a lot about that today. It tackles important policy questions. Many people have emphasized that it exports methods and ideas to other fields of applied economics. I'm going to talk a little bit about what I love about it and also say what I think it could be doing even better. To frame that discussion, I want to go back to one way of thinking about quantitative, or sometimes you call structural economics, in the spirit of the Coles Commission, which is we have a recipe, we have data, and we have economic assumptions, and we turn those things into useful conclusions for making decisions. And in I/O, the data are often about things like firms and consumers. And the assumptions might be about their goals and the timing of moves in a game. And the conclusions might be things like what would happen under counterfactual policies we are interested in evaluating. And one of the things that I love about empirical I/O is that it emphasizes clarity about the economic, not just statistical meaning of its assumptions. So maybe my favorite thing, if I had to pick one and stop there, is that empirical I/O emphasizes the need to treat unobservables in the model as economic objects, not just sort of statistical errors. So if we think about our canonical example of a demand model, a modern empirical, where here I've got, the quantity demanded as a function of maybe price and some unobserved factors. A modern empirical I/O economist knows to ask questions like, we look across different markets with different prices and different quantities, why is price varying? And if it isn't just price, if we see that in two different markets that have the same price, quantity is different, why is quantity varying? And what is it other than the factors that determine demand that are determining prices? These are all very essential questions that every I/O economist, every modern empirical I/O economist knows to ask, and it might be good if more people in other fields ask questions like those. Another thing I love about empirical I/O is its emphasis on clarity about the meaning of its conclusions. So in particular, when we think about things like counterfactuals, it's extremely important, and this again came up many conversations today, to be explicit not only about what we're changing, but about also what we're trying to hold constant. What exactly? So if we ask a question like how would a different price change the quantity demanded, or maybe more complex questions like equilibrium questions, a modern empirical I/O economist knows to ask things like, what are we holding constant when we change price? Are we holding constant the value of the unobservable epsilon? Are we holding constant its distribution? Are we holding constant just some features of the distribution? And of course, the answer to those questions has to flow from answers to another question, which is, why do we want to know? What kind of decision are we going to use this calculation as an input to? And that is going to determine how we want to phrase the question. Again, a kind of question that folks in empirical I/O routinely ask. I think maybe folks in other fields of economics might want to more routinely ask themselves. Where I think empirical I/O could do even better is to have more clarity about the implications of alternative assumptions to the assumptions that are being used in the given analysis. And I think especially, if I could pick one thing, it would be to be clearer, find ways to be clearer about what is most important and why. And if, again, we think about our canonical example where we're trying to estimate the effect of price on quantity demanded, our answer is going to depend on things like what we assume about the shape of the demand curve, or maybe the supply curve if there is one in our analysis, the distributions or the determinants of the unobservables in the model. And I think a modern empirical I/O economist, thanks in part to some of the people in this room, knows to ask questions like, would my conclusion be identified under weaker assumptions? Could I, in principle, reach a conclusion about my questions of interest under weaker assumptions? And the rich literature on nonparametric identification has given us lots of incredibly valuable tools for answering that question. And the modern empirical I/O economist might sometimes even ask, not only could I in principle reach a conclusion under weaker assumptions, but actually, can I go ahead and do that quantitatively in my data? I see Giovanni's here, and there's been really interesting work on nonparametric estimation. So that's an area that I think has been growing, at least in the time that I've been involved in the field. A question I think the modern empirical I/O economist does sometimes ask, but could ask more often, is if the assumptions changed, how would my conclusions change? And maybe even more importantly, how can I teach my audience something about that relationship? So let me say a little more about that by way of an example drawn from labor economics. Let's say that you are the first person to regress the log of earnings on years of schooling. Let's say that your name is Jacob. Now, that does a little bit of a disservice to Jacob Mintzer because actually his paper is way richer than that and super cool. And actually, I don't think he was the first person to run that regression. But let's just for the sake of having an example, let's imagine that's the scenario you're in. And so you run that regression and you regress the log of earnings on years of schooling and you get a coefficient and you put it in your paper. Now, one interpretation of that coefficient is that that is a really good estimate of the causal effect of an incremental year of schooling on the log of earnings. That's possible, but that's only true under very, very special assumptions. Probably many people in the audience for that research don't believe that. Many people, for example, might believe, and here I'm going to want to point, so I don't know how, maybe I should just stand up so I can point. Yeah, many people might believe that those who get more schooling, is it okay if I stand up, Günter? Okay, cool. That people who get more schooling tend to be more able and so would have earned more otherwise, so that there's positive ability bias. So those people think that you have overestimated the causal effect of schooling on earnings, and so the true effect is something smaller than what you reported. And there might even be some people who say, I think the more able people, they leave school early to found big companies and, become titans of industry. And so actually there's a negative ability bias. And so I think your estimate is actually an underestimate of the causal effect of schooling on earnings. Well, what that means is that it might be that every single person reading your paper thinks that your estimate is wrong, in the sense that nobody really thinks it's an estimate of the causal effect of schooling on earnings. But still, every single person who reads your paper learns something useful from it about the causal effect of schooling on earnings, right? And that's a kind of magic of interpretability. And this is a point that I associate with this brilliant paper by Conley, Hansen, and Rossi. I see that Chris is actually hiding behind a beam up there. I don't know if you can see him there. And of course, we know that Peter's here. So I think that's an interesting example to think about. Now, let's contrast that with a different situation, which is one that's more familiar to the folks working in the fields we're talking about today. So let's go back to our canonical example of the demand model. And there, of course, it's harder to represent the space of assumptions on a line. So I'm making up like a hypothetical topology on assumptions. But just to, if you bear with me, we could imagine that one axis might be what shape we're putting on the demand function, and one axis might be what shape or what other kind of economic structure we're putting on distributions of unobservables. And we can imagine that there's different assumptions we can pick inside this big space. And the researcher might be here at this green star. And if they're a conscientious researcher, they might have a table somewhere in the back of their paper where they also show you what happens if you pick a few different possible assumptions at these purple pluses. And so you can get a sense of the sensitivity to a few different possibilities. And if they're really cool, and they really, really, really want to get their paper into econometrica, then they might even show the full set of possible estimates that you could get under a whole set of assumptions. That's really cool. And take a set estimation approach. But let's say that you're somebody who thinks that the most plausible set of assumptions is over here at this orange triangle, or even over here at this one. How are you supposed to know how to move as you move in the space of assumptions, how you should expect to be moving in the space of conclusions, the way you did in the example before about the returns to schooling? So even if, for example, you may know that you're inside this, you're helpfully nested inside this nice identified set, how are you supposed to know where in it you live? Not clear. So an open question that I think the field could think more about and say more about is, if audience members disagree with the assumptions of the researcher, what can they take away from the reported conclusions? And I'm not going to talk about what I think about how to approach that, and I'm certainly not sure that I have it all figured out. It's something I've worked on in work with Isaiah and work with Matt Jensko and others. So I'll just leave it there as something that I think we could be thinking more about. Okay, I'll sit down as I conclude. I will say again, I think modern empirical I/O is just incredibly successful in tackling important policy questions, in exporting methods and ideas to other fields of applied economics. I think that there are opportunities for it to have even greater reach and even greater success by finding ways to enable audience members to interpret its findings under alternative assumptions. Thanks.
So I usually have a very strong accent, which makes it hard to understand me. And now I have a terrible allergy, so which makes it even worse. So that's the warning. I was going to put in a lot of stuff about how I like I/O, because I like I/O, but I expected that there would be a lot of I/O people talking about how they like I/O, so I don't have to do it. And think I was right about that. So I'm going to go to talk about what I was asked about. I think about causal inference. I don't know how you think about causal inference in 10 minutes. I want to think about a particular example of causal inference. I want to start with a very nice paper by Baron Hale, a general market share model. And it's a great paper, very flexible model. It nests a lot of discrete choice, even continuous choice models. And that is nice non-parametric identification results, which every time I get the paper to JP, someone was citing that when I did this. I mean, it's nice, but it's not, I would say, particularly useful because it either lies in the completeness assumption, which basically say assume you're identified and you're identified, or full support instruments, which come on for prices, full support instruments, they're not going to exist. So that sort of makes me a little bit less excited about it. And I think it's sort of a bit symptomatic from my reading of part of IO, is that there's a lot less talk about identification of the models we actually use with the data we actually have. And to me, credibility of estimates, of course, boils down to that. I don't want to hear about what you would have done with more data. Or with a different model, I want to know the model you actually estimated, how you identify that given your data. So I want to think a bit about that in this particular setting. This is part of a big project with like a big team list, let's call it that. He's the chief economist of Walmart. We got to randomize prices across thousands of locations for thousands of products. They want to use it for optimal pricing. We only use it to learn about demand models. Okay, I want to show you some examples of what we've been doing. I want to first show you how the estimate of sort of standard demand models depend on the instrument. We're going to construct the instrument using the randomized experiment, also use the standard IO instruments. And then I want to say, and it turns out super robust. The choice of instrument doesn't matter, okay? Which might be good news or maybe bad news. Depends on what you think. This is saying something about instruments being good, even though they're constructed under maybe like questionable assumptions, or maybe the model is giving the result, not the data. So we want to look at that using the randomized experiments and the instrument from that. Think about how different model gives different answers and why. Sort of thinking a bit about along the lines that Jesse talked about. Okay, for sake of time, I have like 7 minutes or 8 minutes. I'm not going to go through it. It's an exciting experiment that John and his team pulled off, randomizing all these goods. We're going to focus on toothpaste because we're going to look at BLP, they're going to be substitutes. We need to featureize this in terms of the products, and also we have some good ways of getting the total market size. Okay, we randomize prices up and down for all products. We have like 2 exogenous price points per line. A line is, what's there? Crest 3D white something. So it's very detailed information about the product. Okay, so now I want to think about first, do these instruments give us very different results than the standard instruments? Okay, so we're going to think about the BLP instruments, differentiation instruments, and combine those and compare to what we get in the same model using the logit and random coefficient model. We just showed some logit estimates. Okay, this is the elasticities. We all know it's going to be like equal to alpha, price, 1 minus shares. Alpha is what we're after. Of course, correlation is going to be 1. Because of logit, it's only going to shift up and down the alpha, the price elasticity. What's remarkable here, I think, is if you look at the y-axis, it's going to be the BLP, randomized elasticity. These are across all these different goods. It's not exactly the same. It's not a 45-degree line. It's a bit shifted down. But it's remarkably similar. What about the differentiation instruments? Same. What about combining them? Same. What about if I do random coefficients? Very similar. Cross-price elasticity is very similar. Okay, great news, maybe. Okay, so that's the glass half full perspective. Maybe we could trust these other instruments. I'm more like a glass half empty guy. So I get suspicious. This is too similar. Is the data important here, or is it the model? There's so much structure in these models that they're not really letting the data speak. Okay, so that's the second part of this paper, which we're just waiting for lawyers to approve. If John is listening to this, he should speed up that part. So now we're taking like, our point of the part is again, Baron Hale, you have this very general model. Logit is a very special case of this. You can kind of show that you can get logit under a series of assumptions. 2 that we're going to focus on is extensibility of the preference shocks. What does that mean? That the same implies that the same random distribution or marginal distributions. Another thing that Hale and Baron allow for is non-separability in preference between inside goods and outside goods. Okay, we're going to derive relaxed stat 2. In that case, you're going to get alpha J. It's going to be product-specific coefficient instead. Intuition is kind of like toothpaste goes with mouthwash. Some are more complementary than others. It's going to give you different substitution to the outside option. We will think about like which of those models work best. Do they still produce the same estimates for a given instrument? Okay, so we're going to go through that. We have some new identification results that help clarify a little bit to me at least what these kind of models actually do and how they map to the data. Okay, in our settings, shares are small. We can ignore them. Okay, it's ignorable. I'm going to show that approximation works well. That's true in many other settings. The first thing we can show, so you get this logit elasticity. I'm going to go to BLP and other models soon. Logit elasticity is going to be alpha price, linear price, with small shares. What's alpha? Alpha is this. What's this ugly object? It's not so ugly. It's the weighted average of the experimental estimates. What are the experimental estimates? It's the effect of the random price on the quantity. Okay, so those are the moment conditions, essentially. It's the weighted average of the moment condition. The sum is on the outside. So you're going to get some weighted average of that. What is that? Well, it's just a regression of an intercept on these things. So that's logit. It takes the experiments, you plot them out, you draw a straight line. That's going to be a logit estimate of the on price elasticity. Okay, not terribly surprising. But now we know the link sort of cleanly, nicely. There's a transparent link between the experiments, the moment conditions, and the elasticity we're after. What about the approximation? Doesn't really matter. Here's where we estimate it properly. What's the result? Well, the result is that logit depends on price levels, not experimental estimates. Okay, you kind of see that already here. Right? You have all these different experimental estimates. All these are different elasticities coming from the experiment. We use all of them in the logit estimates. I get this line. Of course, you can pick any of those you still identified. If I use this product, I will get a low elasticity. This product, a high elasticity. It's going to happen to be the weighted average if you use all of them. So the model is massively rejected. And what you're going to get depends inherently on which experiment you ran. We did all of them, so we can evaluate that. Okay, so logit depends on price levels, not the moments used to identify it. Okay, what about the random coefficients? Okay, we have the same results. Random coefficients, this is the elasticity. I'm focusing on price for now for the sake of time. Small share approximation. Here's a new result. You remember how logit is linear in price? BLP is quadratic in price. Okay, same thing. Just instead of being linear, it's going to be quadratic. Why the quadratic term? Well, you know, the selection. So it's going to be this is a quadratic term. Instead of being just alpha p, it's going to be expected alpha plus this. This reflects a selection that low alpha guy is going to purchase more of the higher price goods. Okay, you get that from a Taylor approximation around the heterogeneity. Okay, you can show that's identified too. How is this estimate identified? Well, it's going to be a regression like before, but it's not going to be a regression of the experiments on an intercept. It's going to be a regression of the experiments on an intercept and a slope. Another way of getting the BLP estimate, instead of going through the whole non-convex optimization, it's going to be approximately the same as taking the moment conditions and the moments you use, running a regression of those on the intercept and the slope. Do they look the same? Very much. I mean, not exactly, because you have random coefficients on the characteristics and so on, but it's a pretty good approximation. What does this tell me? Well, in this case, I need 2 experiments to identify the model, or 2 instrument values. So you can take any pair of those, construct a line, and you can get an estimate of the coefficients in the BLP model. Are they going to be different? You can draw your lines yourself. They're going to be massively different. Okay, so the model is massively rejected, and it's very sensitive to which of those pricing experiments we would include. Okay, so then what does that mean in terms of the data? Well, remember, this is a logit, linear prices. We all know that with small shares. Random coefficient, not linear, it's quadratic instead. Maybe that's better, maybe it's worse. It's different at least. And it's completely uncorrelated with the moments that you use to identify the model. Okay, why is it so uncorrelated? Because it's so heavily over-identified, right? So you're trying to fit all these combinations. If I just chose one of those instruments, it would of course fit it perfectly. But then we'd be very sensitive to which one I chose. Okay, so to me, this is kind of like interesting because it sort of suggests something about what's actually going into the identification of these models. So we think, let's be constructive in our data. What it seems to be going on is that different goods have very different own price elasticities, and it's not really related to price levels. Okay, maybe that's only in the Walmart case or this big company case. Maybe it's not generally true in other settings, but it seems to be what pops out of our data. So let's think about a different model. Let's relax the separability between inside goods and some outside goods. And I can show you we get this model. Instead of a J coefficient on this, you're going to get an I coefficient on this. Okay, you can derive it directly from Hale and Berry. So now you get elasticity that's specific to J. You get a J-specific price coefficient. Okay, we have the same kind of approximation results, small shares. We know exactly how it now is identified from the experimental estimate. We plot it out. You can't see all the dots in the background there, but this is very correlated with the moments that identified, almost by construction, because you close exactly identified. It was also for other random coefficients. And it turns out that in our data, elasticities don't really depend on price levels. So it gets that right. So that's kind of an example we're working on. We're kind of excited about thinking about alternative specifications of demand and using those experiments to sort of validate and learn about that. Sort of the broader picture that I'm curious to in the discussion is, when I read this like new IO, first of all, it's amazing that you guys get the term like new IO. Imagine like a labor conference and someone said new labor. I mean, at least 5 people in the room would be like, oh, that's my labor, that's my labor, that's my labor. There's a lot of agreement among IO people about what new IO means. I don't think Jim and Josh and Chuck and those guys would agree on anything about what new labor would be. So, which is both scary and interesting, I think. But in any case, this is kind of what I think. It's an incredible good goal to think about institutional details and to learn about things, get instruments, model stuff. But if that's the case, why are the models so similar? Whenever I go to IO seminar, whenever I see a talk, it's always the same demand model. And that's surprising. And it reminds me of this funny TV show. And to me, it's sort of a sign that you guys are not really following up on the promise of the new IO of modeling each industry with particular care.
Okay, so floor is open for discussion and questions.
Really cool panel. Thanks, guys. I wonder, I got the sense from your talk that a lot of the way you think about causal identification here is really in terms of measurement, like correctly identifying parameters. But a lot of what we do in IO is extrapolation to policy counterfactuals, right? Like if for a setting that has primitives that look like XYZ that happen to match my data set in one setting or another, here's what I would expect the policy to do. How do you think about causal inference for that? Because it seems a little bit different than getting the right alpha parameter.
Great. Yeah. So thanks very much for the question. So I guess the way I would think about it is in some sense, I guess I would say both, I would think of a lot of structural IO and a lot of the sort of, again, I struggle for the right term, but say like late descended, reduced form, credibility revolution, pick your favorite term, literature, right? I guess I would say those are both literatures that are focused on causal inference, right? And right, in the sense of we're interested in saying sort of, if we take action A versus action B, if we do policy A versus policy B, what's sort of the difference in what happens? And the way I think about the difference is sort of in sort of structural IO, many other structural literatures, right? The sort of primary focus is on sort of prospective causal questions, right? So it's basically this, as Steve was sort of saying, this policy has never yet been implemented. And we want to predict sort of what would happen if it were to be implemented. Whereas in a lot of the sort of quote unquote reduced form literature, it's much more basically both, it tends to be retrospective, right? Because much of that literature doesn't impose enough on the outcome model that you can answer prospective questions. So you're sort of limited to retrospective questions. And because you're sort of trying to answer it retrospectively, you necessarily are averaging across a wide variety of instances, right? So in that literature, I could do something like a conditional average treatment effect and say, on average, in the past, if I imagine, I had something that I thought was, a good instrument for whether a merger got approved, or some set of things I could condition on where the merger approval was as good as randomly assigned, all sorts of issues one could take with that, but imagine I have it. Then I could say, sort of in retrospect, on average, for firms that were of a similar size to the ones I currently have, what were the effects of allowing that merger, right? That's sort of the retrospective question I could answer. The promise to me of a lot of the structural literature is, of course, that's not actually the question I'm interested in, right? I want to know what's the effect of allowing this merger. And I think to answer that prospective question, I have to impose some version of model structure. And I think what I sort of was trying to get at with my, what I was trying to get at in my slides or in my remarks was just that, right, I think to answer the question we actually care about, I absolutely have to impose structure. And I would say, almost certainly, if folks are using quote unquote reduced form or retrospective estimates to answer prospective questions, they are imposing some kind of structure, right? Because otherwise, I have no idea of how the future relates to the past. The thing that I think is great about empirical IO or a lot of structural fields is folks are making that structure explicit. And then the benefit that opens is we can then do systematic analysis retrospectively of how well are our prospective estimates doing for the things that have already happened. Where necessarily to have power, that's going to be at a lower level of resolution. But at a minimum, it seems useful sort of for the things we can look at retrospectively. I think it would be useful to try to do that more systematically than it seems we currently are. So that's sort of how I was thinking of the connection there.
Further questions?
This goes back to Peter's talk where he was mentioning that, double machine learning or something and just throwing in all the controls wasn't providing reliable estimates of experimental effects. And I guess, how do you guys think about what we should be controlling for? And probably there's theory belongs in there somewhere, but where does it belong, and how do we pick these controls?
I have opinions here, but I'm also happy to defer to my co-panelists if one of them wants to start. But
I agree with Barry and Haley's endogeneity in demand and supply is not about controlling for stuff. And they have a very good discussion of how that's a fruitless task. I mean, it's inherent endogeneity, simultaneity is like Chuckmansky, Havelmo, Bright. So I don't see how machine learning might help us about picking the right functional form on the price relationship or something like that, but that's about it. So yeah. It's a great discussion in the 2014 paper, which I recommend.
Yeah, and my view is very, very similar. I mean, I would basically say, right, we sort of, teach in sort of Econ 101 that like regressing, or, at least metrics 101, regressing quantity on price. Do I call that demand or do I call that supply? And like, there's a huge problem there, right, due to the simultaneity. And if I say I regress quantity on price, but I control for a rich set of covariates, it's not clear that, right, again, unless I'm sort of willing to go all the way to say, no, once I get there, I'm basically going to say that my set of covariates is so rich that the price faced by consumers is as good as randomly assigned once I condition on my covariates, or alternatively, the price faced by suppliers is as good as randomly assigned once I condition on my covariates. I still haven't solved the problem of I'm regressing quantity on price, and I don't know if I'm getting supply or demand.
No, it was a question for Magne. Thank you for your provocative talk. If we are looking at retrospective merger analysis of prospective merger studies, it's almost by definition because the market shares are not small. So I wanted to ask how that would work in the context of your presentation.
I mean, we kind of have two kind of results in that paper. One is the last one mapping the parameters to the moment from the instrument. That doesn't require the small share approximation. But the small share approximation is useful for kind of getting this like alpha I plus the variance term. For that we need it. And I think like BLP with small shares and large shares is just dramatically different models because the preference is going to enter the, just think about like logit. You have like, this is equal to like alpha P1 minus S. When S is small, it's like alpha P. If you solve for optimal price, like constant marginal cost, then you say that elasticity only depend on marginal cost. That's nuts, right? Why don't it depend on preferences? So like BLP with like small shares, or not BLP, it's like this whole sort of machinery with small shares is really a different animal to me. And if you look at like McFadden, it was like choosing between two things. So a lot of the concern, or like a lot of it relying on for the theory approximation, not identification, it's generally a mapping that links the moment to the things. I think it's interesting itself. But I'm very concerned about discrete choice for small shares. I think it's really missing the heterogeneity part. I don't know if Steve agrees, but it's a different animal.
So I guess, I mean, Magne, everybody, thanks a lot for the provide. But in terms of going towards the IO++, you know, I wonder, so maybe one example I want to give. So my very cursory understanding of machine learning or computer vision is that these guys had a lot of these standard data sets and they all trained these models, and then they had these test sets. And they really tuned their models to get at these, you know, standardized public data sets well. Now, one issue is like, we wish we had your Walmart experimental data. Right, so in a sense, but can we somehow maybe find an infrastructure where there are these randomized price experiments out there, and there's a data set out there? Anybody who comes up with, you know, BLP++ has to go there and pass that test first, and then, you know, say, look, you know, we can actually fit this experimentally induced data with our new model, rather than hoping that we are getting is based on our assumptions. You know, might that be? Now that's less, you know, econometric thinking. Maybe more, we have to pool our resources to come up with a research organization to discipline the approach. But I'm very much with. So I came from background engineering, where you build a structural model, and then you build the circuit and check whether it works or not. If it doesn't, the model's out the door. Here, I always find myself building the structural model, making the simulation, and stopping there. And maybe, you know, the next item to add to the job market list is that we actually ran the experiment to validate our model. Of course, it's going to make, you know, people do PhDs for 8 years rather than 6. But what's your take? I mean, what's the way forward? Maybe like give it.
I mean, PANEL1 is one way to go. It's going to require you back to kind of like make an assumption about how an observables vary over time, which is kind of a nightmare. But it's not going to be, I don't know, to me, it's all going to be like case by case. Like take like the BLP instruments. If you think that, like draw like the Hotellings line, if you think it's random whether you're close to many competitors or far away, if that's a good approximation, maybe it is in new industries. They haven't thought about what they produce. Maybe it's a good instrument. In other industries, probably not a great instrument. It kind of has to be like case by case. I don't really understand this kind of what's going to be the new way to find instruments. It's like be Steve Levitt, be clever, find something clever. How do you train people to be that? I don't know. Like I wish I was like that. So therefore, I work with Walmart. So you see what I'm saying? I don't think it's going to be a single solution to these things. You like be clever, work with people, argue case by case, and that's my biggest problem with IO+. Is I don't think they show a lot of respect going into other fields. Same models, same tools, and just like economists do when they go to other fields of science too. Where's all this about institutions? Pay particularly careful attention to institutions. Zero price goods. Really, you're estimating like BLP with most goods have zero price, public schools? You know, probably not obvious model to me, but anyway, so I think IO+ opens up a lot of tension with like the goal of the new IO.
So I guess I have a somewhat related thought, which is just I think I mean, you sort of you're taking the sort of example of the machine learning literature where people have these example data sets. And I think a huge advantage to that literature is basically that we sort of know whether a given model is succeeding, right? Like if I have a huge data set of cat videos and dog videos, and I'm trying to say, is this a cat video or a dog video? I know whether I got the prediction right. And exactly as you're saying, I think a huge challenge with a lot of counterfactual estimation exercises or causal estimation exercises in all areas of economics is we don't get to observe the ground truth, right? And that I think that's actually part of, for me, what fed into my thinking that a useful thing to talk about here was retrospective analyses. Because very often we don't observe the ground truth, but there are cases where we do get to observe what actually happened. You know, there are lots of mergers, right, where in advance of the merger, people are building models and they're arguing about those models, and then the merger either happens or it doesn't, right? So I think I totally agree that, like, I think getting to the scale of data that folks have in machine learning, I think is really hard. But I think that there could be huge benefit in us being a bit more systematic in trying to collect data sets where we actually did counterfactual prediction and then we see what happens. It's going to be far short of the sorts of scale of the data that you have in machine learning. And in cases where you can run a genuine large-scale randomized experiment, right, that's going to be way cleaner. But I also think it's important that there are some types of questions that are going to be much more amenable to experimentation than others, right? Whether I allow a huge merger to happen, probably we're not going to randomize that at scale.
I think maybe just to add, I think I'm basically in agreement with everybody. I think maybe one way to tie these things together is in the machine learning context, the goal of the literature is to have something that runs out of the box and solves all these problems generically, immediately with zero tuning. That's like the gold standard. I don't think, from what we heard today and just my general sense of the field, that's not the goal of empirical I/O. The goal of empirical I/O is to have econometric tools that we can combine with domain knowledge to make useful statements. And so, whereas the machine vision people don't want you to have to, talk to the computer for a while to tell it what a cat is, they just want it to work. We want another step. So if there was a data bank of experiments like you're envisioning, the process for testing the methodology would be a little more intricate because it would involve having, experts decide which model to use, then estimate the model, then see what it predicts, then compare that to the experiment. That seems feasible, but it's just a little bit of a different goal than the goal of the machine vision literature, where you download a Python library, and just run it out of the box.
Actually, just to chime in on that a little more, I think this point of structural modeling requires we think people should think carefully about what they're doing, and they should think carefully about the context, and they should think carefully about the specific industry in which they're building the model. But I also think it's very important to keep that in mind when we're doing the evaluation, right? Because I think the relevant question is not sort of ex post, after knowing what has happened, how well could I possibly predict this outcome in the universe of reasonable assumptions? The question is, prospectively, when I'm trying to predict what is going to happen in this thing, how well do I tend to do on average, right? And if it's basically the perfect structural modeler could do a great job, but I'm doing a bad job, well, that's relevant for me to know.
Do we have any more questions?
Over there?
So Magne, I actually really enjoyed that. You say the problem there is the lack of domain knowledge. So I was curious if you thought that if we had introspected or talked to people in the toothpaste industry, they would have realized that there was a fundamental non-separability between the inside good and the outside goods. Because I feel like the other possibility there is that you've identified something which I think some other people have and have worked on. I think Katja has work on this and other things, which is that the BLP functional form, even with the alpha IPJ, is pretty inflexible with respect to the relationship between elasticities and prices. And that I think you're right. I think that's actually a problem, right? That people will say that elasticities went up or down, when what they really just mean is the price went up or down. So, for example, I think I'm beating up on BLP right now, but if you put log price rather than price in the utility function, for example, you would have found something else, and that's kind of disturbing. So, for example, I think Koch has suggested, well, something like a Box-Cox transformation, and now we need another instrument for that. Now we need something else richer. But I wonder if what you've discovered is just that particular functional form is not as flexible in that dimension as, and I think some other people discovered some similar things as we would have hoped.
What's a bit interesting in our setting is that we can estimate some of these cross-price statistics because we basically randomize like thousands and thousands of goods. And we do empirically see that different inside goods are different degree of complementarity to the outside goods. And you're talking to the Walmart team that's part of this paper. I mean, it's not like we kind of made up these things. They're not stupid. They kind of know in the joint pricing what they're going to price high and low together. So I mean, so sort of, I didn't have time to go through it, but I can show kind of like a series of these all very precisely estimated cross-price statistics, just cross-price effects between like, you know, this toothpaste and this mouthwash, this and this floss, similar like ketchup. I mean, like in the US, people use ketchup, some ketchup for steaks, some ketchup for hot dogs. To me, it's like beyond me, but you see that coming out in the data too.
They're completely different. One of them we don't call
Exactly.
ketchup.
So kind of.
Barbecue sauce?
A1 sauce.
I mean, anyway. So we do actually see some of this stuff, and of course, not all that you're going to see it, but I think kind of the point is more like it's remarkable to me, like how similar in labor we have this problem. Like every labor market paper that search is kind of using the same kind of model. Like we're studying imperfect competition in the U.S. labor market as if it's one labor market. Okay. You guys don't do that, but still the models look awfully similar when you start looking at submarkets. And to me, it might be that it's like universally the best model. Happens to be this perfect specification from Berry and Hale. Seems unlikely. Or it's more like, you know, we don't really care about the estimates. You're going to make a method point. In my paper, I'm going to make this method point. So never mind what the estimates. You're going to make the same in all other dimensions except this new innovation. And that's kind of the job market papers I see. They don't really care about cereal or cars. They want to keep it the same except this new innovation. And that's how research gets reproduced and it becomes an echo chamber. And I've been worried about that.
I essentially wanted to say a version of what Magne just said. I think from the outside, because I'm not a producer of this literature, it's marvelous that everybody wants to both take a methodological step forward and in the same paper get the right answer. That's great. It's ambitious. It's what we should be doing. But it's really hard to do. And mostly you take a methodological step forward and you make a heroic assumption and you make some, you know, something new and you get an answer, but it's probably the wrong answer. And then it takes just years and years, maybe decades, to make everything work the way we want it to and answer all the questions that have come up today, which doesn't mean that it's not a worthwhile journey. But I think sometimes these things are in tension.